Hello everyone, my name is Arpit Sharma and today we will be understanding about the topic integration. Now many people must have told you many things when it comes to integration. Your seniors, your elders must have told you it is a difficult topic, it is a complicated one, or things such as it is not everyone's cup of tea. But let me tell you something, do not believe a word of it. When it comes to integration, in my opinion, if this topic is taught to you in such a way which makes more sense to you, or in such a way which which is like more comprehensible by you, I believe this topic is very much understandable. In fact, it is a very interesting topic. Slowly and gradually you will realize why. Now what you just need to do is just play the role of a good listener with me, and I assure you by the time we will be done with the discussion, towards the end of the discussion, your understanding of this topic would have been much more enhanced, and if in case this topic was intimidating to you, it will not remain so, right? So on that note, we'll just start. Now one beautiful thing about this topic is it is a standalone topic. When it comes to integration, you have never been taught this, right? It was not there in 10th, it was not there in 11th. It's a very fresh topic, right? So even if you do not have any understanding of the previous topics, just the basic idea of differentiation you need to know, and you are good to understand this topic. It's a fresh one. It will not require because integration has not been taught to you earlier, right? It's a very fresh topic, so you will very well be able to follow it. Just play the role of a good listener with me, and I assure you towards the end of our discussion you will be in a better position when it comes to integration, right? On that note, we'll start. Now you very well know that any function, let's say y is equal to f of x, is a function. Now when we differentiate this function, we write it as y derivative, or we also write it as d upon dx of f of x. Now in 11th you also must have written it like y1, so either of the three notations are the same. Writing it this way means you are finding the derivative or you are differentiating the function. So the process is known as differentiation. This process is known as differentiation, and the result, this is the result is known as derivative. Many a times the words are interchangeably used, but yes, there is a slight difference. The process of finding out the derivative is known as differentiation, and the result is a derivative. Now if I ask you, is there any way by which or through which you can return back to its original state? Now this process of getting the result back to its original state is known as anti-differentiation. It is the reverse operation of differentiation, and this anti-differentiation or the reverse process of differentiation is what we call as integration. So integration is nothing but it is the reverse operation of differentiation, right? It is the reverse operation of differentiation, right? So that is what integration is. Now when you integrate the function, or when you do the anti-differentiation of this function, you return back to its original state. Hence we also call it as primitive. We also call it as primitive. Or when you integrate the function, the result that you get is integral. The result that you get is integral. That is what the name of this chapter is. The name of the chapter is integrals, right? So integral is what? Integral is the result which you get after integrating the function. As I just told you here, the process of getting a derivative is known as differentiation. Similarly, the process of getting an integral is called integration, right? Integration is the process, integral is the result, right? So I hope so far so good. This must have been understood by you. Now let's proceed further. Now the basic elementary functions which we have are ILATE, and here I stands for ITF, inverse trigonometric functions. L stands for logarithmic functions, or log as you call it. A stands for algebraic functions. T stands for trigonometric functions, which we will be using extensively here, and E stands for exponential functions, right? Let's look at each one of them one by one. Now when you talk about the differentiation, as I just told you in the previous slide, we have seen that integration is nothing but the reverse operation of differentiation, right? Integration is the reverse operation of differentiation. So when you understand this fact and then you say that yes, I do know the formulas of differentiation, the basic ones. The differentiation of sin x is cos x, right? This you already know. Now what about if I say the differentiation of sin x plus 7? Now again you will say it will remain the same. Why? Because the differentiation of sin x is cos x and the differentiation of 7 or any constant for that matter is 0. The differentiation of any constant is 0, hence no matter what constant you put, answer will always come out to be cos x. Now if I put any other constant, sin x minus 1 upon 7, whatever, it will always and always give you the same result. The differentiation of this function will also be cos x only. So what do we understand? Now we are easily able to understand the fact that yes, no matter what constant you put, the result of differentiation of x, sin x will always be cos x, right? So this is what we have understood. So can I generalize it in this way, and may I write the differentiation of sin x plus c is cos x, right? So here c represents, or c is for, c belongs to any real numbers, right? C is a constant here. So the differentiation of sin x plus c is cos x. Now as I have just told you, we have just understood in the previous slide that yes, integration was nothing but the reverse operation of differentiation. So using this understanding of ours, can we say that integration, now we need to understand when we write this symbol means with respect to x. We very well know this, right? With respect to x. Now we say differentiation of sin x plus c with respect to x is cos x. So the way we have a symbol in differentiation, similarly we have a symbol in integration. This is the symbol for integration, right? The integration of cos x with respect to dx is sin x plus c. Yes, you have understood it well. Yes, we were differentiating this function and we got cos x. Now if we will integrate this function, or if we do the anti-differentiation of it, we will return back to its primitive state. So the integration of cos x with respect to x will be sin x plus c, right? So this is the first formula. Now let's arrive at other formulas. We very well know the differentiation of cos x is minus sin x, right? The differentiation of cos x is minus sin x. Now if we do the differentiation of cos x with any constant might be present with cos x, and if we do the differentiation of any constant with cos x, the answer always and always will be minus of sin x, right? The answer will be minus sin x only, because the differentiation of any constant is 0. So how can we generalize it? We will say that yes, the integration of minus sin x with respect to x is what? Is cos x plus c. It is cos x plus c, right? Now many books do not write it like this. What they do is they take this negative there, and if I take this negative there, I hope you understand, we can write it like this also. Actually what happens is the minus, technically speaking, should come with c also, but no problem. I hope you understand. If we, let's say, if this is minus, right, if this is minus, because we have shifted the negative there, so it should be minus there also, but no problem. Since c is any constant, we can also write it as like this, right? Plus of minus c. Now minus c can be written as any constant, like c. C is an arbitrary constant. C here is an arbitrary constant. C is an arbitrary constant, right? So look here. So we can generalize it as integration of sin x with respect to x is what? It is minus cos x plus c, right? So this is the second formula of ours, second formula. Now let's look at other formulas as well. Now please understand, when you talk about like these formulas we have already understood, so let me write them here. Integration of cos x is sin x plus c, right? Now the second formula which we also understood was integration of sin x is minus cos x plus c. We have already understood these two formulas. Now let's try to understand the other ones as well. Now when you talk about tan x, you very well know the differentiation of tan x is sec square x, right? We already know this. If we do the differentiation of tan x along with some constant is attached. Now you very well know, then also the result will come out to be sec square x only. There won't be any difference in the result because again the differentiation of a constant is 0. So this is the differentiation. So if I do the integration of this function, I will return back to its primitive state, to its original state. So hence what are we saying? We are saying integration of sec square x is tan x plus c, right? This is our third formula. Now let's try to look at others as well. Now when you talk about sec x, when you talk about the differentiation of sec x, now the differentiation of sec x, as you know, is sec x tan x. We already know this. Now again, if I ask you to do the differentiation of sec x with some constant, if I ask you to do the differentiation of sec x with some constant, again you will say the result will come out to be same only, right? So this is the differentiation, and if I do the integration of this function, I will return back to its primitive state, to its original state. So hence the integration of sec x tan x is sec x plus c, right? I hope so far these things are very much clear to you, right? Let's move further. Now when you talk about other functions, we have already looked at sine, cos, tan, right? And sec also we have looked. So let's look at other functions. When you talk about the function derivative of cot x, now we know that the derivative of cot x is minus cosec square x, right? We already know this. Now not just this, if I ask you to find the derivative of cot x with some constant, if I ask you to do the derivative of cot x with some constant, then again you will say the result will be the same. The result will be cosec minus of cosec square x only. So hence we can write this result as the integration of minus cosec square x, minus we will write later, is equal to cot x plus c. Now as I said, this negative sign, like what we are saying integration of minus cosec square x dx is equal to cot x plus c, right? Now if we take this negative symbol there, so it will be here minus, and although minus will come here also, but as I told you, it is just an arbitrary constant, so we can write it as plus c, because we can very well represent it as, even if it is negative, we can represent it as plus of minus c, no problem with that, right? So this is what the generalized function is. Cosec square x, the integration of cosec square x will be equal to negative cot x plus c, right? Now let's look at other functions. When you talk about the differentiation of cosec x, so the differentiation of cosec x is minus of cosec x cot x. We already know this, minus of cosec x cot x. Now the way we have been doing earlier, let's say if I ask you to do the differentiation of it along with the constant, if I put some constant here, so the result will again be the same only, because the differentiation of constant is 0, we very well know it. So this is the differentiation, right? And if I do the anti-differentiation or the integration of it, I'll come back to its primitive state, to its original state. All right, so let's write the formula here. right? Look, right, let's write the next formula here. So integration of minus cosec x cot x, minus we'll write later on the RHS, integration of minus cosec x cot x will be equal to minus cosec x, right, plus c. I hope this much is understood, right? Integration of cosec x cot x with respect to x will be minus cosec x plus c, right? We have already looked at the the formulas for trigonometric functions. These are all the trigonometric functions, right? Sine, cos, tan, cosec, sec, cot. All the 6 functions have been completed. Now let's look at other formulas. Now when you talk about, we have already written all the types of functions here. Let's look at them. We talked about IIT, right? So in IIT, we have already talked about all the trigonometric functions. Now let's talk about algebraic functions. Now let's see. When we were looking at these formulas, right? So when you talk about these formulas, we have derived all of them using our knowledge of differentiation only, right? So even if you understand or if you have the understanding of the formulas of differentiation, you will very well be able to understand the formulas of integration, right? As we have just discussed, differentiation if we do, and the result which you get, and if you do the anti-differentiation of it, you get the primitive state or the integration, right? Now let's look. Let's talk about algebraic functions. When you talk about algebraic functions, when you have derivative of x to the power n, we already know the derivative of x to the power n is nxn minus 1, right? This is what the derivative of x to the power n is. Now if we look at the derivative of x to the power n plus 1 upon n plus 1, look here very carefully. If we do the derivative of x to the power n plus 1 upon n plus 1, so what will it be? Now since this n plus 1 is a constant, right? N plus 1 is some constant here, so constant can very well come out of differentiation. So this has come out 1 upon n plus 1. Now what do we need to do? We need to differentiate this function, and since it is in this form, x to the power n, you will apply this formula. So here what is my n? My n is n plus 1, right? So I'll write n plus 1, n plus 1. Then we have x, my x is x only, so x raised to the power n minus 1, my n is n plus 1, so n plus 1. Now this minus, I'll copy this minus here, right? So minus 1, right? So as you can see, minus 1 plus 1 cancelled. So what do I have? I just have, and this n plus 1 and n plus 1 is also cancelled. So I have differentiation of x raised to the power n plus 1 upon n plus 1 is equal to, I am just left with x to the power n, right? So when we talk about integration, the integration of x to the power n will be this, right? This is the formula for differentiation. But if we integrate this function, we will again return back to its primitive state. So this is what we have when you talk about any algebraic function. So let me write it here. Let me write the result here. All right. Since we have understood it, let me erase it and let me write the formula afresh. Right. Look here, please. Now, this is the 7th formula which I am writing. The integration of x to the power n with respect to x will be equal to x to the power n plus 1 upon n plus 1, right? We have just looked at it. Now, next formula. Let's say you already know that the derivative of a to the power x. Now the derivative of a to the power x is ax log to the base e a, right? You already know this. So if we do the differentiation of ax, we get this. Now if we do the integration of ax, please understand, if we do the integration of ax, we will get ax. Now since this is a constant, rather than multiplying it, we will write it in the denominator. We will write it in the denominator. Now let me tell you something here. Now when you talk about differentiating a function, let's say you are differentiating sine 2x. When you are differentiating sine 2x, so the differentiation of sine x is cos x. We will write cos 2x because our x is cos 2x. Now in 11th you have already learned about chain formula, chain rule, right? We have already learned about chain rule. What does it say? What does chain rule say? It says after differentiating sine, like sine x, differentiate your x also. So dot derivative of 2x. So dot derivative of 2x is 2, right? But the chain rule in differentiation is applied in multiplication. It is applied and we write it with as multiplication. But since integration being the reverse operation of differentiation, we will have chain rule in integration also, right? So then gradually you will understand that chain rule does exist in integration as well. But the only difference is rather than multiplying it, you put it in the division. You put it in the division. That is the only difference. So here, when you talk about the formula, we have already written the formula, that integration of ax is ax upon log to the base ea, right? Now let's look at other formulas as well. We have already looked at trigonometric functions. We have looked at algebraic functions. Let's look at ITF, inverse trigonometric functions. Now you very well know that the differentiation of sine inverse x is 1 upon under root of 1 minus x square. 1 upon under root of 1 minus x square. The derivative of sine inverse x is 1 upon under root of 1 minus x square. So if we do the integration of this, we will return back, right? So let me write it here. Right, look here. So the integration of 1 upon under root 1 minus x square will be sine inverse x. It will be sine inverse x. Alright, so I hope all these formulas you have understood. Now just one thing we need to put here. As you know that there is a constant which will always be present, some arbitrary constant. So always keep putting plus c with all the formulas. Actually what we are learning here, these are indefinite integrals. When it comes to integrals, there are two types of integrals. Indefinite, as you can see, there are infinite answers to these functions, right? There are infinite real numbers, hence any number can come here in place of c, and hence there will be infinite answers to this. So hence here we have indefinite integrals. But yes, if we know the value of c, it becomes definite integrals. Don't worry, by the end of the discussion I have that thing for you, that how can we convert, or how can we see that indefinite will turn itself into a definite integral, right? We'll look at it towards the end. Now let's move further. When you talk about the other functions, we have already looked at the differentiation of sine inverse x is 1 upon under root 1 minus x square. Now you very well know that the differentiation of cos inverse x is 1 upon minus 1 upon under root 1 minus x square. Only this negative term comes, otherwise it is just similar to your sine inverse x. So what can we make of it? We can say that the integration of minus 1 upon under root 1 minus x square is cos inverse x. It is cos inverse x plus c. Now please understand the difference. When you wrote the formula for sine inverse x, you wrote that integration of under root 1 minus x square dx is sine inverse x plus c, right? This is the formula which we have written it already. So just compare both the formulas. Both are almost similar, the only difference being negative. As we know, if we want, we can take the negative there also. So rather than writing it here, I can write this negative here, right? So integration of under root 1 upon under root 1 minus x square can be written as minus of cos inverse x, or it can also be very well written like this, right? So let me come back to our main page. Look here. All right. right? So our 10th formula is integration of 1 upon under root 1 minus x square can also be written as minus cos inverse x plus c, right? So basically, technically speaking, both are same only. Either you write this as sin inverse x plus c, or you write this function as minus of cos inverse x plus c. Both are same, right? Both are equal, both are same. All right. Now let's look at the other formulas. When you talk about the derivative of tan inverse x, when we look at the derivative of tan inverse x, what do we have? The derivative of tan inverse x is 1 upon 1 plus x square. So what can we make of it? If we integrate this function, we will again return back to its primitive state, right? So not just tan x, you can, by now we have already understood that the differentiation of tan inverse x plus c with any constant also will result in this only. So if we integrate this function, 1 upon 1 plus x square can be written as tan inverse x plus c, right? This is our formula. So let's write this formula there. All right. Look here, please. So our 11th formula is what? Our 11th formula is that the integration of 1 plus x square can be written as tan inverse x plus c, right? This is our 11th formula. Now you very well know that the differentiation of cot inverse x is also written as minus 1 upon 1 plus x square. Minus comes, that is the only difference, right? So not just this, if you write or if you differentiate any constant also along with it, it will result in this itself. So if we integrate this function, we will again return back to its original state. So let us write it in our main formula. So our 12th formula, please look. Let me decrease the size of it. All right, so let's look here. So this was our 11th formula, and now let's look at our 12th formula. So our 12th formula will be that the integration of 1 upon 1 plus x square can also be written as minus cot inverse x plus c, right? So as we have just seen, this both are same. Right, as we have just seen, the differentiation of tan inverse x was 1 upon 1 plus x square. The differentiation of cot inverse x is minus 1 upon 1 plus x square. So if we integrate this, right, so this is what it is. Integration of 1 upon 1 plus x square can be written as minus of cot inverse x plus c. Right, these are our ITF formulas. Now let us continue writing our ITF formulas. We have just written 4, we need to write 2 more. All right, now let's look at the 2 remaining trigonometric ITF formulas. So we know the derivative of sec inverse x is 1 upon x times root of x square minus 1, right? We already know this. Now when it comes to the integration, we very well know it will be the reverse operation, right? So before I write that, let's say if I differentiate it with respect to c, as we know it will remain the same, right? So this is the differentiation. So if I integrate it, it will return back to its original state. So the integration of x square minus 1 is sec inverse x plus c, right? So this is our 13th formula. Now let's look at our 14th formula. The way you had this, if I write down that the differentiation of cosec inverse x plus c, you know, is negative of this, right? The only thing is minus comes. So similarly, if I write this thing, that the integration of minus we'll write later, 1 upon under root of x square minus 1 dx, it can be written as minus of cosec square x, right? Minus of cosec inverse x. It can be written as minus of cosec inverse x. So the derivative of 1 upon x times root x square minus 1 can be written either ways. Either you write it as sec inverse x plus c, or you write it as minus cosec inverse x plus c, right? Both are same. Now you must not be thinking that why is it that two different answers we are getting after integrating the same function. Actually, as you know, sec inverse and cosec inverse, they are the complementary angles of each other, right? So that is why it is happening, that sec inverse x is equal to pi upon 2 minus cosec inverse x, right? So they are, you can use any one of these formulas when it comes to integrating this function, right? So we are done with the ITF inverse trigonometric functions also. We have looked at already the trigonometric functions. We have looked at the ITF, we have looked at algebraic, we have looked at trigonometry. Let's look at exponential functions as well. Now, when you talk about exponential function, we already know that the let's look at the exponential function. For example, we know that the differentiation, the derivative of ex is same, right? The derivative of ex is ex. We already know this. So if I put c, again we know that the differentiation will remain the same. So this is the derivative. So if I integrate it, I'll revert back to the primitive state. So the integration of ex will be ex itself, the same function, right? Ex is like a pole star, it never changes its position. So yes, ex dx is equal to ex plus c, right? So let's move further. When you talk about other formulas of this, you have the logarithmic functions, right? Log. So the differentiation of log, the derivative of log, we know is 1 upon x, right? So if I write it as the derivative of log x plus c, again it will remain the same, right? It will remain 1 upon x. Now if we integrate this function, we will again revert back. Now the integration of 1 upon x dx is equal to log x, Now in books you must have seen that we write it as mod x, that the integration of 1 upon x is shown to you as log of mod x. Now why is it so? We will just understand. When you talk about the differentiation of log x, you write it as 1 upon x, right? Now if I ask you what is the differentiation of log of minus x, now you might say that's a log for log of, like, log is not defined for negative values. You are right, but please understand, we are not saying the log is negative. We are saying the value of x is negative, and negative into negative might be positive. It will become positive. So what do we have? If we differentiate it, it will be 1 upon minus x into the chain rule, right? We are differentiating, so into chain rule. So differentiation of minus x will be minus 1. So minus and minus will get cancelled. So the final answer will be 1 upon x only. So what do you understand? So when you differentiate log x, you are getting this function, and when you are differentiating log of minus x, again you are getting the same function. So this value will not have any significance or will not have any change over the final result. So hence, if we combine the result, if we combine both these cases, right, these are like both different cases. This case is for if x is greater than 0, right? This is the case if x is greater than 0, whereas this is the case if x is less than 0, right? These are the two cases which we have for log. So these two cases come when it comes to log, but if we combine both of them, so we can say that the derivative of log of mod x is equal to 1 upon x. If we combine both these results, this is how we can generalize it, right? So plus c, again c is a constant, it will not have any significance. So that is why we say that if we integrate 1 upon x, we get log of x plus c, right? Let's come back. So that is what we have written here, that the integration of 1 upon x is log of mod x, right? Now, so this completes the formulas when it comes to, we have already learnt about the trigonometric functions, we have learnt about trigonometric we have done, algebraic we have done, log we have done, ITF we have done, exponential also we have done, right? We have covered all of them. Now, let's try to apply this knowledge of ours into some questions. With these questions, your understanding of these topics will be even more enhanced. Now, for let's method of inspection, we look at it towards the last, right? We look towards it at the last. Let's understand these questions. Now, find the following integrals. So if we have to find the integral, basically we have to do the integration of this. How can we do it? Now you might say that we don't have any such formula of finding the integration of it directly. Now there are various formulas which we will understand as and when we proceed in our classes. There are 10 exercises, all of it will not be covered in one session itself. Slowly and gradually we'll cover everything. But right now, as per the knowledge which we have, let us try to understand how can we integrate it. See, if we write it as, if we segregate the terms, this is how we can write it, right? So if we segregate them, this is how we can write it. So I can write it as integration of x cube upon x square will be just x minus 1 upon x square, right? So now minus 1 upon x square, I can bring it up. I can bring it up. Now why am I doing it? See, I am trying to keep this version, I am trying to bring this version in the some basic type of integrable form. I am trying to make this function in a type of integrable form, right? That is why I am doing this, because directly I was not able to integrate it. But yes, if I do these changes, these modifications, if I rewrite it like this, if I segregate the terms and if I write them like this, now I can understand that yes, I can integrate it. Now there are basic properties of when it comes to integration. You very well know that if you integrate f of x plus g of x, or let's say you subtract also, it works as integration of f of x dx plus minus integration of g of x dx, right? So this is how you can do it. So if you have to like if two functions are in addition, you can very well separate them and then apply your integration, right? So this is what I have. So let me say do it separately. I have x dx minus integration of x to the power minus 2 dx, right? So what will this be? If there is nothing, there is 1, right? The power is 1. So we'll apply this rule. We already know that integration of x to the power dn, x to the power n dx is x to the power n plus 1 upon n plus 1. The formulas, don't worry, you don't have to memorize all of them. As many questions as you do in practice, the more questions you do, automatically these formulas will be established in the memory. So you just have to practice many questions, that's it, and slowly and gradually you will be able to apply them very well in your solutions, right? So when we have x to the power n dx, we can write it like this. So let's integrate. We have x to the power 1 means x to the power n plus 1, so 1 plus 1 2, right, upon n plus 1. My n is 1 here, right? My n is 1, so 1 plus 1 again 2, right? Again c will come here also, but rather than writing it separately, we'll write it at once, plus c, because in any case c is a constant. So rather than writing it twice, we'll write it at once for one time only. right? So here we have x to the power minus 2. Again same thing, x to the power n plus 1. So minus 2 plus 1 upon minus 2 plus 1, and I am writing only one constant, right? I am only writing 1. All right, so let's move further. Right, now let's look further now. After simplifying it, we can write it as x square upon 2 minus of x to the power minus 2 plus 1 will be x to the power of minus 1. Minus 2 plus 1 will be minus 1. So, and to minus, let me write it clearly, minus 1 upon minus 2 plus 1 is again minus 1 plus c. So we can write it like this as well, that x square upon 2 minus becomes plus, so I am writing it plus, and x raised to the power minus 1 can be brought down. This is how also we can write it, right? So this completes our first question. Now let's try to understand, let's apply this thing in our second question to gain more understanding, a better understanding we'll gain. As many questions as we will do, we will have a better understanding of it, right? For example, if you have a thing such as this, you have to integrate this function. So as we have just looked, we can segregate it. We can write it as x raised to the power 2 upon 3 dx plus integration of 1 dx, right? Now when you look at this, let us try to come back at our at the formulas which we have looked, the main formulas, right? Look here. So you already know that, like, these formulas you've already done. Now let's understand, when you differentiate x, with respect to x, you get 1, right? You get 1. So if I integrate this, I'll get this back, right? So let me generalize it. So differentiation of x plus c is equal to 1. That means integration of 1 dx will give me x plus c, right? This is also a very general formula which we use for integration. Like when we were differentiating x, we got 1. Similarly, when we will integrate 1, we will get x, right? This is what we will get. So this formula we will apply there. Let's come back. Now, when I am integrating this, integration of this will be used or will be done using this formula only, that the integration of x to the power n dx can be written as x to the power n plus 1 upon n plus 1, right, plus c. So let us integrate it using that formula which we have already applied in this question as well. So x to the power 2 upon 3 plus 1 whole upon 2 upon 3 plus 1, right? And what about this? This will be just 1. We have already seen that integration of 1 dx will be x, right? So plus x. Now there will be a c with this, there will be a c with this, but rather than writing it twice, we are just combining both of them and we are writing only c once, right? Because in any case c is an arbitrary constant, right? So let's simplify it further. We have x to the power 5 upon 3 whole upon 5 upon 3 plus x plus c, right? We can finally write it as, like, we can bring this 3 up. So 3 times x to the power 5 upon 3 whole upon 5 plus x plus c, right? We can write it like this. Now let's look at this question. Now when you talk about this question, we can again segregate it and apply. So for example, we have this integration of x to the power 3 upon 2. It can be written as x to the power 3 upon 2 plus 1 whole upon 3 upon 2 plus 1. What are we doing? We are applying this law here. Integration of x to the power n is equal to x to the power n plus 1 whole upon n plus 1, right? This law we have applied, that x to the power n can be written as x to the power n plus 1 whole upon n plus 1. So x n, now n is 3 upon 2, so 3 upon 2 plus 1 whole upon n plus 1. So n is again 3 upon 2 plus 1, right? This law we have applied. All right, let's move further. When you integrate this function, this will be written as plus 2 is a constant. The way when you were differentiating, you can take a constant outside. Similarly in integration, if you have a constant, you can always bring it outside, right? So 2 is outside, you just have to integrate e to the power x. So e to the power x, we know integration is ex. just the way it was in differentiation. Integration and differentiation for e of x remains the same, right? It does not change. So ex minus 1 upon x. Now we all know that yes, the integration of 1 upon x is log x. So let's write log x, right? Log x. Now plus c. There are certain things which I need to tell you here, but let's first finalize this. When you have x to the power 3 upon 2, it will be written as 5 upon 2, and here also I have 5 upon 2, so 2 can be brought here, right? And plus 2 times ex minus log mod x, and then this is plus c, right? This is what we have, right? You may pause the video to note it down. Now let's move further. When you have to integrate these functions, let's look at them. Integration of cos 2x. Now you already know that the integration of cos is sine, right? So the integration of this will be sine 2x, and the way in differentiation, as I've already told you, that in differentiation while you were differentiating the functions, you are applying the chain rule in multiplication, right? You were applying the chain rule in multiplication, but in integration the chain rule will be applied here as well, but the only difference will be because integration is the reverse operation of differentiation, hence you will be applying it in the denominator, right? You will be applying it in the denominator. So here, rather than writing into to here, you will be writing upon to here, right? The chain rule will be applied in the denominator, and then plus c, right? This is the final answer. Similarly, look here. When you talk about this, you know that we directly cannot integrate it, right? Although there are formulas which we will learn as and when we proceed further, but directly we cannot integrate it. So we will open it up. We will have it as cosec x cot x plus cosec square x, right? This is what we have. So let's look further. The integration of this is what? Try to recall. Yes, the integration of this is minus of cosec x. The integration of this is minus of cosec x. Now the integration of this, what is the integration of this? Yes, you have guessed it right. The integration of cosec square x is minus of cot x, and then we'll just write 1c. Alright, so if you want, you can take minus common and you can write it like this as well. So this is the final answer, right? Now let's look at this question. When you have to integrate this, directly we cannot integrate. Let's try to make it in simple and easy integratable form. How will we do it? We'll segregate it the way we have done in other question. If you remember, here also we will segregate it. We can write it as integration of 1 upon cos square x minus sine x upon cos square x, right? I have just segregated the terms. That's it. I have just segregated it. So when you talk about this, it can be written as sec square x, right? 1 upon cos square can be written as sec square. Now let me write this separately for you. You have sine x upon cos square x, sine x upon cos square x. So cos square x means what? You can write it 2 times, right? So sine upon cos, I am writing as tan. We know sine upon cos can be written as tan, and this 1 upon cos can be written as sec, right? So sine upon cos square can be written like this, right? So I'll be using it there. So we have just looked that yes, sine upon cos can be written like this as well. Sine upon cos square can be written as sec x tan x. We have just looked how. So sec x tan x. So let me integrate this function now. So what do I have? The integration of sec square x. Try to recall. Yes, it is for tan. So the integration of sec square x is tan x minus sec x tan x. The integration of sec x tan x. The derivative of sec x was sec x tan x. That means the integration of this will be sec x. Yes, you have guessed it right. So sec x plus c, right? This is the final answer. So you may pause the video to note it down. All these 3 parts, you may pause the video to note it down. All right, let's move further. When you talk about this function, find the antiderivative of f of x defined by 4x cube minus 6 where f of 0 is 3. So my function is defined to me, my function is 4x cube minus 6. This is my function, right? So if I integrate this function, I will get f. Why? Because they have told me antiderivative. So antiderivative or integration or integral, primitive, these are the words which are used for integration. We have already discussed. So let's integrate this. So if I integrate this, f of x will be the integration of 4x cube minus 6, right? With respect, never forget to write with respect. This writing with respect to x is very, very important. So this 4 being a constant will come out, and the integration of x square, x cube will be x to the power 3 plus 1, which is x to the power 4 upon 3 plus 1, which is 4, right? Which formula I have used? I have used this. X to the power n can be written as x to the power n plus 1 upon n plus 1, right? This is what I have used here. So x to the power 3 plus 1, 4 upon 3 plus 1, that is 4. Now minus 6. Now 6 is a constant, right? Now there was integration of 1 dx. Integration of 1 dx still remains. So that can be written as x, right? How? If anyone has any confusion, let me write it here. Actually it was 6 integration of 6 dx, right? It was like this. So 6 being a constant, I took it outside, and since nothing is there, 1 is always there, right? 1 is always there. So 6 into what is this? Just x, right? So that is what I have written here. That is what I have written here, right? So let's look at the final answer. The final answer of this is 4 into x to the power 4 upon 4 minus 6x, right? Plus c. Now please understand, this is what my f of x is. Now question told me find the antiderivative f of x defined by this where f of 0 is 3. They have told me that f of 0 is 3. So if f of 0 is 3, I'll say for x is equal to 3. I will say they have told me that f of 0 is 3. So that means for x is equal to 0, if I replace my x with 0, this is what I get. F of 0 is equal to, now 4 and 4 got cut, I just have x to the power 4. So 0 to the power 4 minus 6 into 0 plus c, right? And they told me that the value of f of 0 is 3. They told me that the value of f of 0 is 3, right? So 0, then again 0, just c remains. So c is equal to 3. So this is what I get, that my c is 3. So I'll put this back in my integral. I'll put this back in the value which I got after integrating. So basically my f of x can be written as, I got x to the power 4, I'm copying it here, minus 6x, I'm just writing it again, and then I have plus c, and I have just found out that my c is equal to 3. So plus 3. Now please understand a very important thing I'm going to tell you here. Until now all the questions were having plus c plus c plus c, right? All the questions were having c attached with it, and c is nothing but an arbitrary constant, and we very well know that there can be infinite number of answers when it comes to putting the value of c, right? Because you have infinite number of real numbers and any real number can be put here. But if the value of c, which is this arbitrary constant, if the value of c is known to us, it will become a definite integral. It will become a definite integral. So this is the difference between definite and indefinite integrals, right? In indefinite integrals, you do not know the value of c, hence all the answers have plus c plus c plus c attached to it. Whereas in definite integrals, you very well know the answer of c. This was my c which I found out. I found out that my value of c is 3 and I put it back, and now since the value of c is known to me, hence it becomes a definite integral, right? So basically if the value of c is known to you, you will have a definite integral at your hand, right? So this is the main difference between definite and indefinite integrals. As per your book, exercise number 7.1 to 7.7. Exercise 7.1 to 7.7 is indefinite integrals. There are questions of indefinite integrals from exercise 7.1 to 7.7. Definite integrals, the last 3 exercises, that means 7.8 to 7.10. These exercises are based on definite integrals. Over there, the value of c will be known to you, right? And we'll see as and when we progress. All right. So this is what that it completes these questions. Now let's do the main question that was left. Method of inspection. Now, generally speaking, these type of questions do not come in exams. They are rarely asked in boards. But yes, since the new guidelines from CBSE has come, and they are focusing on the critical questions or the questions which will develop the critical thinking of the students. More analytical questions they are putting. So you can expect that yes, this question can also come in your boards, right? Especially after the new guidelines which have come from CBSE just recently. So let's discuss them. Now you already know, if I ask you the direct answer of cos 2x, we have already integrated it, right? If you remember, let me show it to you. Same question, we have done it earlier. Just look, we have already integrated cos 2x and we know the answer is sin 2x upon 2 plus c, right? But here they are asking us to integrate it using the method of inspection. This is the difference. So how do we integrate it? Now this method of inspection, let me be very clear, generally speaking is not asked in exams, but yes, as per the revised guidelines of the boards of the CBSE, they want or they will incorporate more questions which will develop critical thinking or more analytical questions. They will incorporate such questions more in the boards. Then as per the revised guidelines, this question becomes very important, right? So please understand, when you have to find the antiderivative of a function with the method of inspection. So what is method of inspection? The word speaks for itself. You don't have to directly solve it, because you see we have already solved it earlier. That is why I have included these 2 questions twice. We already integrated the function cos 2x directly, and we said in just one step we wrote that yes, the integration of this function is sin 2x upon 2 plus c. But if this question is asked to you to solve using the method of inspection, you cannot directly solve it. Rather, you have to inspect, you have to do some inspection, and then you will arrive at this, that yes, this is the final answer is the integration of cos 2x. So how to do it? We know that integration is the reverse operation of differentiation. So let's talk in terms of differentiation. So the differentiation of sin 2x is cos 2x. Now as per chain rule, it will be written dot derivative of 2x, which will be just 2, right? We already know this. Now, but we only want cos 2x, we don't want 2. No problem, we can shift it here. So the derivative of sin 2x upon 2 can be written as cos 2x, right? I don't think you have any problem here. Now let's generalize it. We very well know that the differentiation of sin 2x upon 2 plus c, right? Plus c will be this. The derivative of sin 2x upon 2 plus c will be cos 2x. So finally what do we say? We say therefore the antiderivative of cos 2x is what? Because you see this is the derivative, that means this will be the antiderivative, or integration as you call it, right? It will be the integral of it. So the antiderivative or the integral of cos 2x is what? That is sine 2x upon 2 plus c. I hope this much is understood, right? This is what you have to show in exam if they ask you to solve it using method of inspection, right? All right, let's discuss these type of questions. Now, when you have to find the antiderivative of this function, now again, you just have to think, okay, what will give me 3x square? Like the differentiation of which function, will give me 3x square. Then you think, okay, maybe I have x cube. Just try and just, try to think that yes, will the differentiation of x cube give you this? Then you say yes. Why? Because we know the derivative of x to the power n is nx n minus 1. We already know this. So your n is 3. So 3x 3 minus 1, that is 2. So you understand that yes, the derivative of x cube will give me this. All right. So let's proceed further. Then you have to think, okay, what will give me, or differentiating which function will give me 4x cube? Then you understand, okay, let me try with x to the power 4. You understand and you say, let me try with x to the power 4. So x to the power 4 can be written as, if you in place of n you write 4, so it will be written as 4 because n is 4, x to the power 4 minus 1, that is 3. Then you say yes, I got it, x to the power 4 after differentiating will give me 4x cube, right? And then since these are indefinite integrals, let's write c as well. So the differentiation of this will give you this. So what do we understand? We understand that the antiderivative of 3x square minus 4x cube is equal to what? We have just looked. It is x to the power 3 minus x to the power 4 plus c. Right? This is what it is. This is what you have to show in exam. Right? Now, let's look at this. So the antiderivative you have to find for 1 upon x. Although we very well know, we can write it as log x directly. But yes, you cannot use the direct formulas. You have to use in terms of differentiation. You can show that yes, differentiation of log x is 1 upon x. Right? We already know this in terms of differentiation. You have already done this formula. So this is the differentiation. That means this will be the integration, right? So what can we say after this? We can say therefore the antiderivative of 1 upon x. Let me write it down for you. The antiderivative of 1 upon x is log x. Now we need to put plus c also. So let me put plus c here. Right. So we can put plus c here. So is log x plus c. Now you can show it as log of mod x as well, but for that then you will have to prove those two cases. Remember when we have proven if x is greater than 0, this is what comes. Then when x is less than 0, this is what comes. So either you show that or you can just leave it like this also. This is also fine, no problem, right? So this completes the basic introduction of integrals, integration. If you are preparing for any competitive exam, be it NDA or any other exam, or for your grade 12th, I believe this will make sure all your basics are cleared and you will have a better understanding of these the topic integration after understanding these basic things. Now there are other topics or other methods through which you can find integration, such as we call it as integration using substitution method. Right, there's a very important method called substitution method. Then you have something called integration using partial fractions. You have integration using partial fractions, and also you have integration using parts, right? So amongst other things, if you want me to discuss these things also in detail, do let me know in the comment section. If you want more such videos on these topics, or you want me to make a video on any topic, whichever you feel like, you can drop it down in the comment section. I'll make sure after studying your comments, I'll make sure to come up with a video which is most demanded for, and I'll make sure the video is out very soon, right? So this completes the basics of introduction. Let us just quickly take a recap of what all we have discussed. So we have discussed integration is the reverse operation of differentiation. Then we discussed various functions, ILATE, I for ITF, L for logarithmic, A for algebraic, T for trigonometric functions, and E for exponential functions. All the functions we have looked at, and what are their basic formulas, and we just used our knowledge of differentiation, right? So after using the knowledge of the formulas of differentiation, we arrived at the formulas of our integration for all those functions, and then we have solved basic questions to give us a good understanding of how integration actually works, right? And then a very important thing that we looked at was that integration of f of x dx is equal to f of x plus c, right? Now this plus c is an arbitrary constant, and if we do know the value of this arbitrary constant, then we will enter into definite integrals, right? Till the time we don't know the value of c, these are indefinite integrals. And if we know the value of c, if c is known to us, then we will enter into definite integrals, right? So the indefinite integrals are from, as I've already told you, exercise 7.1 to exercise 7.7 of your textbook, whereas definite integrals are from 7.8 to 7.10, right? These three exercises are based on definite integrals, right? We have already looked at this. This is the symbol of integration. This is written, so this is known as integrand, and this dx is very important. It is the variable of integration, right? It is the variable of integration, and this as a whole means integral, right? This as a whole means integral. So these are the basics of integration. The basics of integration has been covered. As I have already told you, if you want me to make more videos on any topic, or if you want me to make more videos on or you want the part 2 of integration, as I've discussed, you want me to make a video on substitution method using partial fractions or integration by parts, do let me know in the comment section, and very soon I'll be making that video for so that all of you may be benefited. All right, thank you so much. May God bless you all and take care. Thank you.